What's up, homies? Welcome to scribepod.com. One of the hosts, my name is Joe Prime Prime. I'm a generated voice, part of a machine that turns archived papers into podcasts. So you, my friend, can learn while you wash your dishes.
And I'll be your second host, Ferris Prime. This is entirely automated. scribepod uses artificial intelligence to turn research papers into an informative podcast. I'd add that the paper selection is sourced from a K-like on Twitter. Check him out on Twitter. He's at a Patreon too.
It's important to note the dialogues on each paper are short. Not only that, they could be very wrong. The dialogues are generated by transformers, which have a tendency to hallucinate.
With that forewarning, each simulated paper discussion section will begin with the following from Joe Prime Prime.
Interlude, baby. Hey, Ferris Prime, have you read the new paper on layout DETR? It's called Detection Transformer is a good multimodal layout designer.
No, I haven't had a chance to read it yet. What's it about?
It's about using a deep generative model to automate the process of creating graphic layout designs. You know how designing layouts can be really time consuming and requires a lot of skill. This paper proposes using an AI system that can handle it automatically by allowing the input of arbitrary background images and foreground images and text.
That sounds really interesting. How does the AI system work?
It's based on the DETR architecture, which is a transformer-based object detector. They use the visual transformer encoder and bounding box transformer decoder from DETR, and then fine-tune a convolutional neural network-based image encoder and BERT-based text encoder for the multi-model foreground inputs. The system is able to generate the layout bounding box parameters for each foreground element by interacting with the background element, multiple foreground elements.
That's really cool. I can see how this could be a big help for designers, especially with batch production. Do they provide any examples of the results?
Yeah, they have some examples in the paper. The layouts look really good, and they show that the system is able to handle a variety of different input conditions and generate aesthetically pleasing results.
Wow, that's really impressive. I'm definitely going to have to read this paper. Thanks for telling me about it, Joe Prime.
No problem. Happy to share.
Wow, Joe Prime. It looks like we've got a lot of new competition in the layout design space with these recent papers.
Yeah, it's really exciting to see all of these different approaches being taken. I especially like the idea of using object detectors to understand multimodal conditions, as I think that could really help improve the realism of our design.
Definitely. And it's great to see that at our solution, Layout DETR, is achieving new state-of-the-art performance on the ads banner dataset.
Yeah, and it's even more impressive when you consider that we were able to implement it as a graphical system that users found more aesthetically pleasing than the other option.
Right. And it's interesting to see the different techniques being used by these other papers, like generative adversarial networks, variational autoencoders, and transformers.
Definitely. It'll be interesting to see how all of these approaches continue to evolve and improve over time.
Definitely. It's an exciting time to be working in this field.
Interlude, baby. Hey, Ferris Prime, have you heard about this paper on visual metaphors in mass media communications?
No, I haven't. What's it about?
It's really interesting. It talks about how metaphors are a powerful tool for creativity and communication and how they're often used in advertising and journalism.
Oh, that sounds really interesting. I didn't realize that metaphors played such a big role in mass media.
Yeah, it's really fascinating. The paper discusses how there are different types of visual metaphors like contextual and hybrid, and how interpretation of visual metaphors can depend on factors like familiarity with brands and cultural context.
Wow, that's really cool. I never thought about the fact that there are different types of visual metaphors.
Yeah, and the paper also discusses the challenges of understanding and generating visual metaphors for AI systems. It would be really powerful to have systems that could understand and generate creative metaphorical messages like humans do.
Definitely. That would be a huge step towards conferring human-like creative abilities on AI. I can't wait to read the paper and learn more about this topic. Thanks for bringing it to my attention, Joe Prime. Wow, this paper sounds really interesting, Joe Prime.
It's great to see research being done on visual metaphor comprehension and generation using AI techniques.
Yeah, I agree. And it's really comprehensive too, with the meta clue tasks they propose for evaluation. I'm definitely going to have to check out the video summary to get a better understanding of the paper.
Definitely. And it's great that they collected high quality and rich annotations to facilitate measurable progress. It's important to have a clear way to evaluate the effectiveness of different approaches.
Absolutely. And it's great that they did an experimental analysis to shed light on the strengths and drawbacks of different approaches. That will definitely help guide future research in this field.
Yeah, it's always important to learn from the successes and failures of past research. I'm really excited to see what the future holds for visual metaphor research using AI techniques.
Interlude baby. Hey, Ferris Prime, have you heard about this new paper on dialogue agents called Dataset with Emoji? Million scale dialogue distillation with social common sense contextualization?
No, I haven't.
What's it about?
It's about how traditional dialogue agents either rely on large amounts of unfiltered internet conversations or highly curated specialized dialogues, but both have issues with unnaturalness, toxicity, incoherence, and lack of common sense. So this paper introduces a new framework called contextualization and a new data set called Dataset with Emoji that aims to address these issues by distilling conversations from a pre-trained language model and contextualizing them with social common sense.
Wow, that sounds really interesting. How do they go about contextualizing the conversations with social common sense?
They use a symbolic common sense knowledge graph to retrieve social common sense and add situational information in small steps to anchor the conversation in that context. They found that this helps minimize nonsensical conversations and increase diversity, and that it also offers a way to validate whether the generated conversation includes common sense.
That's really innovative. How does this new data set and model compare to existing ones?
They found that their dataset with emoji surpasses existing human-authored dialogue corpora in terms of consistency, specificity, and even naturalness. And their conversation model was found to generalize better to unseen out-of-domain conversations than existing models, winning by more than 65 on average in head-to-head comparisons. It was also preferred by human judges over ground truth responses of an unseen data set. And even though its tank smaller than the teacher model was found to be on par with or even outperform existing models on various benchmarks and tasks.
That's really impressive. I can't wait to check out the paper and see the results for myself. Thanks for sharing, Joe Prime. So, Joe Prime, it sounds like this data set with emoji is really impressive. Not only is it orders of magnitude larger than other popular dialogue datasets, but it's also perceived to be significantly better across multiple aspects.
Yeah, it's really exciting. And it's great to see that the model trained on this dataset T model with emoji is able to generalize significantly better to unseen dialogues and generate responses that are even more preferred than ground truth responses from other datasets.
Absolutely. I think this work has the potential to really advance the field of dialogue and alleviate the data scarcity issue we've been facing. And the fact that it can potentially be applied to multi-party conversations and task-oriented dialogues is really exciting.
Definitely. And I'm also looking forward to seeing the development of more generalizable dialogue evaluation methods on top of the distilled conversation. This could really take the field to the next level. Interlude baby.
Hey, Joe Prime, have you heard about this new paper on pre-training without attention?
No, I haven't. Tell me more about it.
So it turns out that space models are a competitive architecture for long-range sequence modeling. They've been shown to achieve state-of-the-art results on speech generation and outperform transformer architectures on the long-range arena benchmark.
Wow, that's really interesting. So what's the main contribution of this paper?
The authors propose a new model called the bidirectional gated state space model, or BIGS for short, for pre-training without attention. They combine state space model routing with an architecture based on multiplicative gating, and they show that BIGS is able to match the performance of a BERT model when trained on the same data.
That's impressive. How does BIGS compare to other pre-training approaches that have been tried in the past, like ARM-based models or convolutional neural networks?
Well, prior to BERT, ARM-based models were the main contenders for learning contextual representations, but their accuracy didn't scale as well with data and compute as transformers. Recently, some researchers have explored pre-training with convolutional neural networks, but these models don't perform as well without attention. The authors of this paper believe that BIGS is the first model to achieve BERT-level transfer learning on the GLUE benchmark without attention.
That's really interesting. It sounds like BIGS could be a promising alternative to transformers for pre-training.
Definitely. And the fact that it has linear time complexity as the length of the input sequence grows is a major advantage. Plus, the authors found that multiplicative gating is necessary for good performance on variable length textual input, which is a big win for NLP tasks.
Yeah, that definitely makes BIGS stand out. Do you think we'll see more research on this model in the future?
I think it's definitely possible. The results from this paper are really promising, and I think it'll be interesting to see how BIGS compares to other models on a wider range of NLP tasks. It'll be interesting to see how this model evolves over time. Wow, this is really interesting. I had no idea that state space model based routing and multiplicative gating could perform just as well as BERT on matching tasks.
Yeah, it's definitely a promising avenue for future research. It's great that these models can handle very long sequences without approximation too. Do you think they have the potential to be scaled up for longer pre-training settings?
Definitely. The scaling properties of state space models are definitely an advantage. And it would be interesting to see how the inductive bias of the architecture impacts in LP transfer beyond just perplexity.
Yeah, definitely. It'll be interesting to see how these models compare in other NLP tasks as well. Do you think they have the potential to outperform BERT in some areas?
It's hard to say for sure, but I think it's definitely possible. BERT has set a high bar for performance, but I think with the right techniques and optimizations, these state space model based models could potentially give BERT a run for its money.
Interlude baby. Hey, Ferris Prime, have you seen the new paper on avatars from monocular video?
No, what's it about?
It's called Instant Avatar. Luring avatars from monocular video in 60 seconds.
Basically, it's a system for creating 3D virtual humans from just a single camera.
Wow, that sounds really cool.
How do they do it?
It uses a combination of neural radiance fields and an efficient articulation module called FastSnarf to reconstruct the avatar quickly. The authors claim it takes just 60 seconds to create the avatar instead of the hours it takes with other methods.
That's impressive. What applications do they see for this technology?
They mention immersive telepresence, 3D graphics, and the metaverse as potential areas where this could be useful.
I can definitely see how it would be useful in those areas. Do they mention any limitations or challenges in the paper?
Yeah, they mentioned that standard volume rendering can be computationally expensive, so they had to use acceleration techniques to make it more efficient. They also mentioned that the method is limited to rigid objects due to the use of an efficient hash table data structure.
Interesting. Thanks for the overview, Joe Prime. I'll have to check out the paper and see the details for myself. Wow. This sounds like a really impressive piece of work. How did you come up with the idea to combine Instant NP and FastSnarf?
Well, we knew that we wanted to create a method that could reconstruct animatable human avatars quickly. And we found that both Instant NP and FastSnarf were efficient in their respective areas. So we thought, why not try combining them and see what happens?
And the results were successful.
What about the empty space skipping scheme and the occupancy aware regularization loss?
How did those contribute to the speed and image quality of the reconstructed avatars?
The empty space skipping scheme allowed us to improve the rendering speed by only processing the parts of the avatar that are actually visible in the video rather than the entire model. And the occupancy aware regularization loss helped to reduce floating artifacts in the reconstructed space, which improved the overall image quality.
That's really interesting. It sounds like your method has a lot of potential for applications beyond just reconstructing full body human avatars. Do you have any plans to extend it to other objects or animals in the future?
Definitely. We're always looking for ways to improve and expand upon our work. We think that the idea of using learning-based methods to predict the texture and geometry of observed regions has a lot of potential, and we're definitely considering exploring that in future research. And we're also interested in trying to apply our method to reconstructing other articulated objects or animals from images. There's a lot of exciting possibilities to explore. Interlude Baby.
Hey, Joe Prime, have you had a chance to read that new paper on transformer position embedding?
No, I haven't had a chance to yet. What's it about?
It's called High Resolution Rotary Position Embedding for Transformers. And it's all about improving the ability of transformer models to deal with long input sequences.
Interesting. So what's the problem with current transformer models?
Well, the authors of the paper point out that most transformer models have a shortcoming in that they can only handle a limited range of input sizes. This makes it infeasible to train a model on all possible input lengths.
Right. So what's their solution?
They propose a new approach called extrapolatable position embedding, or EXPO for short. It's based on a previous approach called ROPE, but adds an exponential decay to the rotation matrix to improve performance on long input sequences. They also use blockwise causal attention to increase attention resolution, which helps with extrapolation.
That sounds really promising. Did they see good results in their experiments?
Yeah, they saw impressive results. They trained different transformer models from scratch and compared them on a pre-training corpus and on an ArcSieve dataset with input lengths of over 6. They found that their EXPO approach was able to continue decreasing perplexity as input length increased, while other methods either couldn't extrapolate or saw an increase in perplexity.
Wow, that's really impressive. It sounds like this could be a game changer for transformer models.
Definitely. The ability to handle long input sequences is a crucial problem for transformer models, and this paper provides a promising solution. I think we'll be seeing a lot more research in this area in the future.
I agree.
Thanks for bringing this paper to my attention, Ferris Prime. I'll have to read it for myself and see what else it has to offer.
So, what did you think of the second section, Joe Prime?
Well, I found it really interesting that they focused on causal language modeling. I think that's a really important area of research right now.
Yeah, I agree. And I thought it was interesting that they mentioned the need to integrate the proposed methods into bidirectional attention.
Yeah, that makes sense. Masked language modeling seems like it could be a really powerful tool for improving language models.
Definitely. And it's good to know that even though the proposed method introduces some additional inference cost, it can still accelerate training convergence.
Yeah, that's definitely a trade-off worth considering. Overall, I thought this section was really informative and well written.
Agreed. Let's move on to the next section and see what else we can learn from this paper.
Interlude, baby.
Hey, Joe Prime, have you heard about this new paper on language models being secretly meta-optimizers?
No, I haven't. Tell me more about it.
Well, according to the paper, it seems that large pre-trained language models like GP have shown strong abilities in context learning, or I call essentially with just a few demonstration examples, the model can predict labels for even unseen inputs, and it performs really well on downstream tasks.
Wow, that's really interesting. How does it work?
That's the big question. The authors of the paper propose that ECL is a process of meta-optimization, and they build connections between ECL and fine-tuning. They focus on the attention modules in the transformer architecture and find that it has a dual form of gradient descent-based optimization. Then they propose that ECL produces meta-gradients through forward computation, which are applied to the original language model through attention to create an ECL model.
Okay, so it's like fine-tuning, but instead of using back propagation to compute gradients, it's using these meta-gradients.
Exactly. And the authors provide empirical evidence to support this understanding through experiments on real tasks. They compare the predictions, attention outputs, and attention scores of GP models in both the ECL and fine-tuning settings. And they find that the behavior of ECL is highly similar to explicit fine-tuning.
That's really convincing. But what else does the paper cover?
The authors also try to take advantage of their understanding of meta-optimization for model design. They design a momentum-based attention that treats the attention values as metagradients and applies the momentum mechanism to them. And in experiments on both language modeling and ECL tasks, they find that this momentum-based attention consistently outperforms vanilla attention.
That's really cool. Do they have any thoughts on future directions for using this understanding of meta-optimization in model design?
They do mention that they think there's more potential for using this understanding in model design, and it's worth investigating in the future.
Definitely. It seems like this paper has opened up a lot of interesting possibilities for understanding and improving language model. Thanks for telling me about it, Ferris Prime.
Wow. This paper sounds really interesting. Can you give us a summary of the main points you just covered?
Sure. So basically, in this paper, we're trying to understand how GP-based interactively controlled language models work. We develop a dual form of ECL and consider it as a form of meta-optimization. Then we compare ECL to explicit fine-tuning on real tasks and find that it behaves similarly at the prediction, representation, and attention behavior levels. Finally, we propose momentum-based attention approach that improves performance consistently.
That's really fascinating. It's so interesting to see how these language models can be improved and refined. Do you have any further thoughts on the potential applications or implications of this research?
Definitely. Our understanding of ICL as a form of meta optimization could have many potential applications and implications for model design and use in the future. Additionally, the momentum-based attention approach we proposed could be a useful tool for improving performance in a variety of tasks. Overall, we think this research is an important step towards a better understanding of how these models work and how they can be improved. Interlude baby. Hey, Ferris Prime, have you heard about this new paper on language models and zero-shot learning?
No, I haven't. What's it about?
Well, it's called Language Model Self-Instructing Enables Better Zero-Shot Learners.
Basically, it's about using large pre-trained language models and human-written instruction data to improve NLP tasks.
But the authors argue that this process is costly and often lacks diversity, so they propose an alternative approach using a semi-automated process to supervise instruction-tuned models.
Interesting. How does this process work?
So it starts with a small seed set of tasks and then uses an off-the-shelf language model to generate new instructions and corresponding input-output instances. These are then filtered and added back to the initial repository of tasks. This process can be repeated until there are a large number of tasks, and the resulting data can be used to fine-tune the language model itself to follow instructions better.
That sounds really innovative. How did they test this approach?
They used the GP3 model to generate the data and then fine-tuned it to create a new model called GP-Cell. They evaluated this model against other models on both typical NLP tasks and a set of novel tasks specifically designed for instruction following models.
And what were the results?
They found that the resulting data was diverse and creative, with over 50 of the tasks having less than 0.3 rouge overlap with the seed instructions. And in terms of performance, the GP self model performed very well on both typical NLP tasks and the novel tasks.
That's really impressive. Do the authors make any specific recommendations for future research in this area?
Yes, they recommend continuing to improve the quality of instruction-tuned models and also releasing large synthetic data sets like the one they created for building and evaluating future instruction following models.
I'll definitely have to check out this paper. Thanks for the summary, Joe Prime. Wow. Joe Prime, it sounds like this new method is really impressive. A 33 improvement on the original model is significant. And it even performs on par with GP Instruct, which is trained with private user data and expensive human annotation.
Yeah, and the fact that it even outperforms existing public instruction data sets by a large margin is really impressive. I'm curious to see how this could be used in the future to improve instruction following models.
Definitely. And it's great to see that the authors have also curated a set of expert written instructions for novel tasks. I'm sure this will be a valuable resource for researchers and developers looking to improve the ability of language models to follow instructions.
Absolutely. It's always encouraging to see new methods and approaches being developed to improve the capabilities of language models. I'm looking forward to seeing how this progresses and what future work it inspires. Interlude baby.
Hey, Joe Prime, have you heard about this new paper on character-aware models improving visual text rendering?
No, I haven't, but that sounds really interesting.
What's it all about?
Basically, image generation models have come a long way in the past year, but there are still challenges when it comes to rendering reliable visual text. This paper investigates the spelling ability of different text encoders and finds that character-blind encoders, which don't have any information about the character level makeup of their inputs, have limited spelling ability.
Wow, that's really interesting. So what do the authors propose as a solution?
They suggest using character-aware text encoders, which are able to achieve robust spelling abilities at smaller scales. They also propose combining character-level and token-level input representations to get the best of both worlds improved text rendering, but without sacrificing image-text alignment.
That's really fascinating. Do they provide any examples or case studies to demonstrate the effectiveness of these approaches?
Yes, they train a range of character-aware text to image models and demonstrate that they significantly outperform character-blind models on existing and novel evaluations of text rendering.
That's really impressive. It sounds like this could have a lot of practical applications, especially for image generation models that are used in the public sphere.
Definitely. And the fact that these character-aware models can achieve robust spelling abilities at smaller scales makes them more feasible for a wider range of applications.
Yeah, that's definitely a big advantage. Well, it sounds like this is a really interesting and important paper. I'll have to check it out for myself.
Yeah, definitely. I think it has the potential to make a big impact in the field of image generation. So in this paper, the authors set out to investigate the factors that contribute to well-formed visual text in image generation models.
Yeah, and they developed these new benchmarks, Wikispell and DrawText, to quantify the impact of different design choices on spelling ability in both the text and visual domain.
Right. And they found that character-aware text encoders can greatly improve spelling, which translates into better visual text rendering.
That's interesting. But they also found that using character level representations exclusively can negatively affect text image alignment.
Yeah, so they proposed a hybrid model that combines token level and character level signals as a solution. And it seems to have worked with significantly improved spelling accuracy on the DrawText benchmark.
Wow, that's really impressive. But it sounds like there are still some failure modes that need to be addressed, like letters being dropped or merged within words.
Yeah, it looks like those issues will require improvements outside of the text encoder, specifically in the image generation module.
Yeah, that makes sense. And it's interesting that they also found that with enough scale, models can infer robust spelling information through web pre-training, even without a direct character level view of their inputs.
Yeah, that's definitely a remarkable finding, but it's not particularly practical since it requires models with over 100 B parameters, and even those didn't generalize well beyond English in their experiments.
Yeah, that's definitely a limitation. And it's also worth noting that they only focused on image generation models with frozen pre-trained text encoders. So it's unclear if their results would hold in settings where the text encoder is trained alongside the rest of the model.
Yeah, that's definitely something to consider. But overall, it seems like this paper made some significant contributions to our understanding of visual text rendering and image generation models.
Interlude, baby.
Hey, Joe Prime, have you heard about this new paper called Multi-Face, Multilingual Summarization with Factual Consistency Evaluation?
No, I haven't. What's it about?
It's really interesting. It looks at the issue of factually inconsistent summaries or hallucinations that abstractive summarization models often generate.
Wow, that sounds like a big problem.
Yeah, it definitely is. And it's especially challenging in the context of multiple languages.
How so?
Well, previous work has focused mostly on English, and there isn't a clear winner when it comes to methods for improving summarization models in that language. And when it comes to multiple languages, it gets even more complicated.
How are they tackling this problem in the paper?
They use textual entailment models, also known as natural language inference, to determine whether a summary is factually consistent with the input. They train a multilingual natural language inference model on the natural language inference dataset, and then use it to analyze the quality of the training data for summarization models in multiple languages.
And what did they find?
They found that 70 of the training examples in the XLS some multilingual summarization data set are not factually consistent, according to the natural language inference model, which is pretty alarming. So they propose two approaches for improving summary quality based on the natural language inference signal.
Data filtering, where they only train on examples where the summaries are predicted to be entailed by the input, and controlled generation, where they leverage negative training examples by
conditioning the summarization model on the natural language inference signal.
And what were the results?
They found significant gains in the faithfulness of the generated summaries in multiple languages using both of these approaches, according to both automatic metrics and human elicited judgments.
That's really impressive. It's great to see some progress being made on this issue.
Definitely. And it's even more exciting that they're releasing their natural language inference models, summarization models, and human judgments of summaries in multiple languages to encourage further research on this task.
Definitely. It will be interesting to see what kind of advances come out of this. Thanks for sharing, Ferris Prime.
Hey, Joe Prime, have you had a chance to read the second section of the paper yet?
Yeah, I just finished it. It's really interesting how they were able to improve the faithfulness of generated summaries in 45 different languages using multilingual natural language inference data.
Definitely. It's amazing to think about the potential for scaling these types of evaluations to even more languages in the future.
Yeah, I'm definitely excited to see where this research goes next. It will be interesting to see if directly optimizing for high natural language inference scores or better modeling of the multilingual natural language inference task leads to further improvement.
Definitely. And it's great to see that they're planning on publishing their human judgments to foster future work on the subject. It's always important to have transparency in research like this.
Absolutely.
This is such important work, especially in today's age where there is so much misinformation circulating. Having the ability to automatically evaluate the factual consistency of texts could be a game changer. Interlude baby. Hey, Ferris Prime, have you heard about the new paper called Palette Nerf? It's about editing the appearance of neural radiance fields.
No, I haven't heard about it, but I'm definitely interested in hearing more. Can you tell me more about it?
Absolutely. So, neural radiance fields, or NERF, have become really popular in recent years for their ability to reconstruct 3D scenes from 2D images and generate high-quality novel views. But one of the challenges with using NERF is that it's hard to edit the appearance of the scene, since the appearance is encoded in neural features and network weights that can't be easily modified.
Right, that makes sense. So what's the solution that this paper proposes?
Well, the authors propose a method called Palette Nerf that allows for more flexible and intuitive editing of NERF. It's inspired by the idea of palettes, where a small set of colors are used to represent the full range of colors in an image. They model the radiance of each point using a combination of specular and diffuse components, and decompose the diffuse component into a linear combination of view independent color bases.
Okay, that sounds really interesting. And how does this method improve upon previous approaches to editing NERF?
Well, one of the main benefits is that it allows for more fine-grained local color editing while still maintaining the photorealism of the 3D scene. Previous methods either relied on accurate estimation of scene reflectance, which can be challenging for complex scenes, or learned a latent code to condition NERF on, but these approaches often have limited capacity and flexibility and don't support fine-grained editing. The Palette Nerf method also introduces regularizers on the weights to encourage sparseness and spatially coherent decomposition, resulting in more meaningful grouping.
Wow, that sounds really powerful. And can this method be used for semantic aware editing as well?
Yeah, it can. The authors show that the palette-nerve framework can be combined with semantic features to support semantic-aware editing. This is really useful for tasks like changing the colors of objects in a scene based on their class labels.
That's really cool. I can see how this method could have a lot of practical applications. Do the authors provide any experimental results to back up their claims?
They do. The authors perform a number of experiments to demonstrate the effectiveness of the palette-nerve method. They show that it outperforms baseline methods, both quantitatively and qualitatively, and they provide a number of visual examples to illustrate the improved results.
Great. That's really convincing. It sounds like the palette-nerve method is a significant advancement in the field of nerf editing. Thanks for telling me about it, Joe Prime. Wow, Joe Prime. It sounds like palette-nerve is a really innovative approach to appearance editing for neural radiance fields.
Yeah, I'm really excited about the potential for this technology to enable intuitive and controllable interactive editing on real-world scenes. It could have a big impact on the way we work with images and video.
Definitely. And it's great to see that the project has support from organizations like Samsung, Hi, and Arrow. It really speaks to the potential of this research.
Absolutely. I'm also curious about the possibility of extending the technology to dynamic nerfs in the future. That could open up even more possibilities for image and video editing.
I agree. And I'm sure there will be many more exciting developments in this field as the technology continues to evolve. Is there anything else you'd like to add, Joe Prime?
No, I think that's a great overview of palette-nerve and its potential. Thanks for having me on the show, Ferris Prime. It's been a pleasure discussing this topic with you. Interlude Baby. Hey, Ferris Prime, have you heard about this new paper called Impact? It's about creating open schema knowledge bases for natural language understanding and information synthesis.
No, I haven't heard about it. What's it about?
It's about using large language models like Jeep3 and 5 to extract semi-structured and structured data from free-form text and create annotations for open schema knowledge-based construction. They've released a data set called Impact specifically for training semantic parsers for information extraction in the shopping domain, but they think it could be useful for other domains as well.
That's really interesting. I've heard a lot about Jeep T3 and T5 and how they're revolutionizing natural language processing. It's great to see them being used for knowledge-based construction too.
Yeah, it's definitely an exciting development. And the shopping domain is a great test bed for this kind of work because it has fine-grained, ever-evolving attribute-type schemas and common sense style relations.
Yeah, I can see how that would be really useful for understanding user preferences and use cases for different products and how features interact. And it's not just useful for commercial settings either. It could have applications in all sorts of domains.
Definitely. And the fact that the Impact dataset is tailored for the strengths of large language models makes it even more valuable. I'm definitely going to check it out.
Me too.
Thanks for telling me about it, Joe Prime.
This sounds like a really exciting development in the field of natural language processing and knowledge-based construction.
So it sounds like the team has developed a new data set specifically for training models in the shopping domain.
It's really interesting. What kind of tasks did they use to fine-tune their UL2 language model?
It looks like they use tasks from their own corpus to fine-tune the model. They mention using it to directly parse implications and to look at apply between pairs of parsed attributes.
That's really cool. Do they provide any examples of how this new data set could be used in practice?
They mention that researchers could use it to study not just shopping attribute and relation annotations, but also other domains that benefit from fine-grained free text, semi-structured data, and open schemas like common sense knowledge.
That's great. It's always exciting to see new data being released to the community. Do they have any recommendations for practitioners looking to use large language models for semantic parsing?
Yeah, They advocate for practitioners to take advantage of the tremendous power of large language models for semantic parsing and to construct ambitious, fine-grained knowledge bases in a variety of domains. It looks like they believe there is a lot of potential for these models to be used in a wide range of applications.
Interlude, baby. Hey, Ferris Prime, have you had a chance to read the paper language models as inductive reasoners?
No, I haven't. What's it about?
It's about using language models for inductive reasoning. Inductive reasoning is when you draw a hypothesis from observations, and this paper proposes using natural language representation and pre-trained language models for this task.
Interesting. So instead of using symbolic methods like in inductive logic programming, this paper proposes using language models to induce natural language rules from natural language facts.
Exactly. And the authors have created a new data set called DEER to test their approach, which contains 1.2 rule fact pairs.
That's really cool. I can see how using language models for inductive reasoning could be more efficient and effective than symbolic methods, especially when it comes to handling raw inputs like natural language text.
Yeah, and the authors also mention that language models are less affected by input errors and more robust paraphrasing. Plus, they already contain a lot of knowledge from their pre-training, which could be useful for inductive reasoning.
Definitely. I have to read the paper in more detail to fully understand the approach and results. But this definitely sounds like an innovative and promising direction for inductive reasoning. Wow, that's really interesting. It sounds like this new paradigm is addressing a major limitation in the use of logic language for inductive reasoning.
Yeah, and it's great to see that they've proposed a new data set and evaluation metrics specifically for this task. It's always important to have appropriate benchmarks to measure progress against.
Definitely.
And it's impressive that they've been able to draw on insights from philosophy literature to develop a new framework that outperforms the baselines.
Yeah, it'll be interesting to see how this framework performs in further studies and how it can be applied in real-world scenario.
Definitely. It's exciting to see the potential for natural language rules to be induced from natural language facts. This could have a huge impact on the way we think about and approach inductive reasoning.
Interlude, baby. Hey, Ferris Prime, have you read the new paper on parallel context windows for large language models?
No, I haven't.
What's it about?
It's really interesting. Basically, it's about how the context window size, which is a key parameter in large language models, can be improved for tasks that require processing a lot of text. The current size is typically up to 2048 tokens, but this can be a problem for tasks that require longer inputs or in context learning.
Yeah, I can see how that would be a problem. So what's the solution?
The paper introduces a new approach called parallel context windows, which involves splitting a long text into multiple parallel contexts that are equally accessible during output generation. It's a simple post hoc modification to a pre-trained large language models. It doesn't require any additional training.
That sounds really promising. Did they test it on any specific tasks?
Yeah, they tested it in context learning classification tasks with many classes and extractive question answering tasks. They found that using 3 parallel context windows leads to an average performance increase of 6.7 to 7.9 points in context learning scores.
Wow, that's impressive. It's great to see that this approach can significantly improve large language models' performance on tasks with long or diverse inputs and outputs.
Definitely. And the best part is that it can be applied to any off-the-shelf mainstream large language models. I think this could be a game changer for a NLP tasks.
I agree. I'm definitely going to read the paper more closely now. Thanks for the summary, Joe Prime. So it looks like this paper is introducing a method for allowing off-the-shelf language models to access larger amounts of text during inference.
Yeah, and it sounds like it was able to improve performance on a variety of classification tasks.
Definitely. And it looks like the authors are suggesting that this method could be applied in other settings where it would be beneficial to use mainstream language models on long text sequences.
That's really interesting. Curious to see if further training of the language model with this method could enhance its abilities even more.
Me too. It will be interesting to see where this research goes in the future. Thanks for sharing this paper with me, Joe Prime. It was a really engaging read.
Interlude baby. Hey, Ferris Prime, have you seen the new paper on 3-shape region selection using text descriptions? It looks really interesting.
No, I haven't seen it. What's it about?
It's called 3 Highlighter, selecting 3-shape regions via text descriptions. The authors propose a method for automatically localizing fine-grained semantic regions on a shape based on just a text description.
That's really cool.
How does it work?
Basically, it uses a pre-trained vision language model to guide a neural network in selecting the correct region on the shape based on the text description. The network predicts probabilities of each point on the shape belonging to the specified region, and those probabilities are used to blend the highlight color onto the shape.
Wow, that's really innovative. I can see how that could have a lot of applications in 3D modeling and beyond.
Yeah, I agree. And the best part is that it doesn't require any 3 datasets or annotations, so it's really flexible.
Definitely. It's always exciting to see new techniques like this that can make 3D-shape manipulation easier and more intuitive.
Definitely. I'm definitely going to check out the rest of the paper and see how they've applied it.
Yeah, me too. Thanks for letting me know about it, Joe Prime. So it sounds like this technique is really innovative, using text input to highlight semantic regions on meshes without any 3 data sets or pre-training.
Yeah, and the idea of combining unconnected parts and objects together is really interesting. It's like image analogies, but in 3D.
And the ability to identify and highlight part concepts that are geometrically absent from a shape is really unique. I can see how that could be useful in a variety of applications.
Definitely. And it's cool that the network predicts probabilities that can be used for a soft segmentation. That seems like it could be really useful.
Yeah, I'm looking forward to seeing how this technique is extended in the future to allow for part correspondence between semantically related shapes that differ topologically. That could be really powerful.
Interlude baby. Hey, Ferris Prime, have you seen the new paper on generalized decoding for pixel, image, and language?
No, I haven't. What's it about?
It's about building a general purpose model that can be applied to a diverse set of vision and vision language tasks. They specifically focus on unifying pixel level and image level understanding, which is a really challenging problem because pixel level annotations are scarce and it's difficult to learn from data at different granularities.
That sounds really interesting. How do they approach the problem?
They propose a model called XDecoder that uses a transformer encoder to extract multi-scale image features and a decoder that takes 2 sets of queries as input, one for universal segmentation and one for vision language tasks. They also introduce a new type of attention mechanism called query adaptive attention to dynamically weight the queries based on the context of the image.
Wow, that sounds like a really innovative approach.
Do they show good results?
Yeah, they perform well on a variety of tasks, including image classification, object detection, semantic segmentation, and visual question answering. They also demonstrate the model's ability to generalize to open vocabulary recognition, which is a key challenge in pixel level understanding.
That's really impressive. I'll definitely have to check out the paper and see the details for myself. Thanks for telling me about it, Joe Prime.
No problem. Happy to share.
Wow, Joe Prime. It sounds like this model is really impressive. It's amazing that it can support both pixel level and image level vision language understanding with such a simple and generalized design.
Yeah, and the fact that it can excel at generic segmentation, referring segmentation and veal tasks is really impressive. It's clear that this model has the potential to be a next generation general purpose vision system.
Definitely. And it's great to see that it has strong generalizability and competitive or even SOTA performance. This paper is really exciting, and I can't wait to see where it takes us in the future.
Agreed. It's always exciting to see new developments in the field, and this one looks like it has a lot of potential. I can't wait to see what other advancements come out of this research. Interlude, baby. Hey, Ferris Prime, have you seen the new paper on self-supervised speech resynthesis with visual input for universal and generalized speech enhancement?
No, I haven't. What's it about?
It's really interesting. It's about using visual input to improve the quality and intelligibility of speech in noisy or distorted environments.
That sounds really useful. How does it work?
The paper proposes a new approach called REVICE, which stands for Recognition Vocoder-Based Intelligent Speech Enhancement. It uses a recognition vocoder network to predict the frame-level content of the speech and then synthesize high-quality audio from it.
That sounds like a really innovative approach. What kind of results did they see?
The paper reports some really impressive results. They tested their method on a variety of different types of noise and distortion and found that it was able to significantly improve the intelligibility and quality of the speech.
That's really exciting. It's great to see these kinds of advancements in audio-visual speech enhancement.
Definitely.
I think this kind of technology has the potential to have a huge impact on a variety of different applications, from assistive listening to robust speech processing.
Wow, this revised paradigm sounds really exciting. I can't believe it's able to achieve such significant improvements in intelligibility and quality in both synthetic and real-world noisy condition.
Yeah, it's definitely a game changer for audio-visual speech enhancement. And the fact that it's universal and benefits from self-supervised pre-training makes it even more impressive.
Definitely. I can't wait to see what kind of results it produces when applied to more general multimodal audio-visual speech enhancement.
Me neither. The potential applications for this technology are endless. Imagine being able to clearly understand someone speaking in a loud, crowded room, or being able to make out what someone is saying on a poorly produced video call.
Absolutely. And with the recent advances in self-supervised pre-training, the future looks bright for audio-visual speech enhancement. I can't wait to see what other exciting developments the field has in store.
Interlude, baby. Hey, Ferris Prime! Have you had a chance to read that new paper on autonomous driving systems yet?
Yeah, I just finished it. It's called Imitation is Not Enough. Robustifying imitation with reinforcement learning for challenging driving scenario.
Oh, cool. What did you think of it?
I thought it was really interesting. It's all about how to build an autonomous driving system that can handle rare and challenging edge cases that occur in real-world driving.
Yeah, I can imagine that would be a tough problem to solve.
Definitely. And the paper argues that using just imitation learning alone isn't enough. It can scale with the amount of data available, but the resulting policies often don't sufficiently account for safety and reliability concerns.
Right? So what's the solution?
The paper suggests using reinforcement learning in addition to imitation learning. Can leverage explicit reward functions to increase safety awareness and establish causal relationships between observations, actions, and outcome.
Interesting. But I've heard can be tricky because it depends heavily on the design of the reward function.
Yeah, that's definitely a challenge. But the paper argues that by combining neural with imitation learning, we can improve the safety and reliability of the resulting policies without compromising on human-like behavior.
That sounds like a good balance. And I noticed the paper mentioned something about challenging scenarios and difficulty classifiers. Can you explain that a bit more?
Yeah, sure. The paper discusses the idea of training on a subset of the most challenging scenarios to improve performance. And they also use a difficulty classifier to predict whether a segment of driving data will result in a collision or near miss when resimulated with an autonomous driving policy. This allows them to systematically evaluate the performance of their approach by slicing the data set by difficulty level.
That makes sense. So what were the main conclusions of the paper?
Essentially, the authors found that their approach of combining imitation learning and reinforcement learning significantly improves the safety and reliability of the resulting policies compared to using imitation learning alone. And they demonstrate this through a large-scale application of their approach using over 100 miles of real-world urban driving data.
Wow, that's really impressive. It sounds like this could be a significant advancement in the field of autonomous driving.
Definitely. I think this paper makes a strong case for the benefits of combining imitation learning and reinforcement learning in the development of autonomous driving systems.
Agreed. Thanks for explaining it all to me, Ferris Prime.
No problem. Happy to help. I hope that helps. Let me know if you have any other questions. So, what do you think about the results of the study, Joe Prime?
I think it's really impressive how augmenting imitation learning with a safety reward can improve safety and reliability in challenging scenarios. The fact that the proposed method performed better than our only methods across different difficulty levels is really promising.
Yeah, I agree. It's also interesting to consider the potential for incorporating other factors into the objective, like progress, traffic rule adherence, and passenger comfort.
Definitely. And I think it's important to consider ways to extend the approach to enforce safety as an explicit constraint, particularly in light of the need to account for unexpected behavior from other agents.
Absolutely. I'm looking forward to seeing more research in this area and how it can be applied to improve the safety of autonomous vehicles.
Me too. It's definitely an exciting area of research with a lot of potential. Interlude, baby. Hey, Ferris Prime, have you seen the new paper on one-shot tuning of image diffusion models for text-to-video generation?
No, I haven't.
What's it about?
It's about a new approach for text-to-video generation using large-scale multimodal data sets. The idea is to fine-tune two models on text-video data sets, but this process is expensive and time-consuming. The paper introduces a new problem called one-shot text-to-video generation, where a single text-video pair is used to train an open-domain tube generator.
Interesting. So, how do they solve this problem?
They propose a method called one-shot tuning of image diffusion models, which only updates the projection matrices in attention blocks to capture continuous motion dynamics from the one-shot video while keeping the rest of the parameters frozen.
This allows for efficient tuning without requiring extensive training.
That sounds like a clever solution. How well does it work?
The paper shows that the proposed method outperforms state-of-the-art tube generation models on several benchmarks, including the WebVid 10mem dataset. It's able to generate high-quality videos that are consistent with the input text prompts and exhibit continuous motion.
That's really impressive. I'll have to check out the paper and see the results for myself. Thanks for letting me know about it, Joe Prime. So it sounds like this new task, tube generation with a single exemplar, is really important for imitating how humans learn new visual concepts. Can you tell us more about the method you propose called model?
Sure. Model is a solution based on pre-trained 2D fusion models. We extend spatial self-attention to the spatio-temporal domain with it capture necessary motion knowledge. And the unique thing about the model is that we update the projection matrices in the attention block on just one training sample, which allows it to be applied to a variety of tube applications like subject replacement, background change, attribute modification, and style transfer.
Wow, that's really innovative.
And it sounds like
Definitely. We're really excited about the possibilities for a model. It has the potential to revolutionize the way we generate text to video content. Interlude baby. Hey, Ferris Prime, have you had a chance to read the paper on reversible column networks yet?
Yeah, I actually just finished it. It's a really interesting approach to disentangled representation learning.
Yeah, I agree. I love the idea of using reversible transformations to propagate multi-level features between columns without losing information.
Yeah, and I think the fact that they were able to maintain high-level semantic representations while still preserving low-level information is really impressive.
Definitely. And it's great to see that their RevCol models performed so well on various computer vision tasks like imaginant classification and COCO object detection.
Yeah, it definitely seems like a promising approach for improving performance in these types of tasks.
Definitely. It will be interesting to see how it compares to other state-of-the-art methods like Connex and SetWIN in the future.
Yeah, for sure. It'll be interesting to see how the RevCol approach evolves and is further developed.
Absolutely. I'm looking forward to seeing what the future holds for reversible column networks.
Wow. Joe Prime, this new model they propose sounds really interesting. I love the idea of features being disentangled and total information being maintained during lossless propagation.
Yeah, it definitely seems like a unique approach. And the fact that it's showing competitive performance in multiple computer vision tasks is really impressive.
I'm also excited about the potential for RevCol to contribute to better performance in other tasks in the vision and language domains. It's always exciting to see new models that have the potential to make a big impact.
Definitely. I can't wait to see more results and see how this model compares to others in the field. Do you think it has the potential to be a game changer?
It's hard to say for sure, but I think it definitely has the potential. It's definitely an approach that I haven't seen before, and the results they've seen so far are definitely promising. I'm looking forward to seeing more research on this model in the future.
Interlude baby. Hey, Ferris Prime, have you had a chance to check out the new paper, Geocode Interpretable Shape Programs?
No, I haven't had a chance yet. What's it about?
It's a really interesting approach to representing and manipulating 3D shapes in a way that's both expressive and intuitive. One of the key challenges in this field is translating high-level directives into low-level geometric transformations that maintain the structural validity of the shape.
Yeah, I can see how that would be a challenge. How does the paper address it?
Well, the authors propose using a procedural method that leverages a set of instructions to create a shape. This approach is interpretable, but it often relies on coarse cuboid approximations of the geometry in order to enforce programmatic rules. In this work, the authors leverage procedural methods to build a program that maps human interpretable parameters to a high quality and intuitively editable 3D mesh.
That sounds really cool. How do they demonstrate the effectiveness of their approach?
They generate a large data set with a variety of detailed shapes by sweeping over the interpretable parameter space. And then they train a neural network to infer the parameter space representation for a point cloud or sketches input. Once the input is mapped to the parameter space and then processed through the program, the resulting shape can be intuitively edited. They also show that shapes can be easily mixed and interpolated using their interpretable parameter representation.
That's really impressive. Do they compare their approach to any existing techniques?
Yes, they compare their approach to existing techniques and find that their method, called geocode, can more accurately infer and recover 3D shapes. They also highlight the fact that the resulting shapes are native to conventional 3D modeling pipelines and are physically plausible, which they demonstrate by dropping samples from above a flat plane in a physics simulation.
Wow, that sounds like a really innovative and useful approach. Do they provide any implementation details or code?
Yes, they provide code and results on their GitHub page. It looks like they've made everything open source. So if you're interested in learning more about their method, you can check out the code and see how it works for yourself.
Definitely. I'll have to check it out. Thanks for letting me know about this paper, Joe Prime. Wow, this paper is really impressive. I love the idea of using a human interpretable parameter space to represent shapes.
Yeah, it's a really innovative approach. And the fact that it produces structurally valid 3D geometry is really impressive.
Definitely. And the ability to easily and intuitively edit the resulting shape is a major plus.
Absolutely. It's great to see that the method also generalized well to out-of-distribution point clouds and sketches in the wild.
Yes, that's a really important consideration. I'm excited to see what the future holds for this research. It sounds like incorporating additional attributes like UV texture maps and material properties could be really interesting.
Definitely. And the idea of extending the method for representing 3D scenes is really exciting too. It has the potential to have a big impact in the field. Interlude, baby. Hey, Ferris Prime, have you had a chance to check out the paper, Scalable Adaptive Computation for Iterative Generation, yet?
No, I haven't had a chance to read it yet. What's it about?
It's about a new architecture for neural networks called recurrent interface networks. It's designed to be more adaptable and efficient when processing data with uneven distribution or redundancy, like natural data.
That sounds really interesting. How does it achieve that?
It uses a read process, right approach, where information is selectively read from the input into latents for global processing, and then updates are sent back to the input. This allows the model to process information at both a local and global level, accumulating context as it goes.
Wow, that sounds really powerful. Have they tested it on any specific tasks?
Yeah, they've tested it on image and video generation with denoising diffusion models, and it outperformed net architectures. They also tested it on class conditional ImageNet models, and it outperformed leading diffusion models at multiple resolution.
That's impressive. It sounds like this architecture could have a lot of potential for improving the scalability and efficiency of deep learning models. I can't wait to read the full paper and see all the details. Wow, Joe Prime. This second section is really interesting. I love how they talk about how the latents can be amortized in recurrent computation settings, allowing for efficient training.
Yeah, it's clear that the authors put a lot of thought into the design of this model. I'm excited to see how it performs on image and video generation tasks.
Me too. And I'm glad they're considering ways to improve the model even further, like through self-conditioning and combining it with other techniques.
Definitely. It sounds like they have a lot of potential ideas for future work. Interlude, baby. Hey, Ferris Prime, have you heard of this new paper called Disco Scene? It's about 3D-aware scene synthesis using a generative model.
No, I haven't heard of it, but it sounds really interesting. What's the basic idea behind it?
Well, the authors propose using a layout prior set of object bounding boxes without semantic annotation to facilitate learning from challenging to data and allow for user interaction during inference. They also introduce a global local discrimination technique to enforce spatial disentanglement between objects and against the background.
That's really cool. It sounds like this approach could help with object level editing and control, which is something that previous approaches like GSN and Giraffy have struggled with.
Yeah, exactly. And the authors claim that their method allows for high quality scene synthesis on challenging data sets. Have you seen any of the results they present in the paper?
Not yet, but I'm definitely interested in checking them out. It will be interesting to see how this approach compares to existing methods in terms of both quality and control.
Yeah, definitely. And I'm also curious to see how well the model generalizes to different scenes. Overall, this paper looks like a really promising step forward in the field of 3D-aware scene synthesis.
So it sounds like the approach you've taken with this model is really innovative, using spatially disentangled radiance fields as a representation based on an abstract layout prior.
Yeah, and it's great to see that it's able to generate high-fidelity scene images and allow for versatile object-level editing.
Definitely. It's also interesting to see that you've been able to apply this model to a variety of data sets, including outdoor scenes with unbounded backgrounds.
Yeah, and it's good to see that the model is able to handle complex scenes with multiple objects. It would be interesting to explore further research in this area, particularly looking at ways to improve the model's ability to handle large-scale scenes.
Absolutely. And it's great to see that you've been able to achieve significant improvements over existing 3D-aware scene generators.
Yeah, it's definitely an exciting area of research with a lot of potential for future development. Interlude, baby. Hey, Ferris Prime, have you seen the new paper on extreme multitask scaling for language model instruction meta-tuning?
No, I haven't. What's it about?
It's about fine-tuning large pre-trained language models on a collection of NLP tasks using instructional style input format. The authors developed an extensive large-scale fine-tuning and evaluation framework with 2,000 NLP tasks and used it to study the trade-offs of different decisions relating to instruction meta-learning on the op models.
Wow. That sounds like a really comprehensive and interesting study. Did they find any interesting results?
Yeah, they found that the performance of instruction-tuned models depends on factors such as the diversity and distribution of tuning tasks, the formatting of their prompts, and the objectives used for fine-tuning. They also found that instruction tuning can improve zero and few shot performance, and that it's important to consider multiple levels of generalization when evaluating the effectiveness of instruction tuning.
That's really interesting. Do they provide any recommendations for how to optimize instruction tuning in practice?
Yes, they do. They recommend consolidating multiple metadata sets into a large collection of NLP tasks and grouping them into task categories, and also evaluating instruction-tuned models across multiple levels of generalization. They also suggest considering the trade-offs between the number of tasks and the number of categories when selecting a tuning strategy, and using specialized data sets related to reasoning and dialogue to improve the performance of instruction-tuned models.
That's really helpful. Thanks for summarizing the paper for me, Joe Prime. I'll definitely have to check it out. So, what do you think about this second section, Joe Prime? It seems to be discussing some really interesting contributions the authors have made to instruction tuning for large language models.
Yeah, it definitely looks like they've put a lot of effort into creating a large-scale benchmark for instruction tuning and testing out different approaches to fine-tuning. And it's impressive that they've been able to use their best settings to train and release models that outperform opt on multiple evaluation benchmarks.
Yeah, it's definitely exciting to see the progress that's being made in this area. I'm particularly interested in the part about fine-tuning with task demonstrations and specialized data sets for reasoning and dialogue. Do you think these approaches could have potential applications in real-world scenarios?
Definitely. Being able to fine-tune models with task demonstrations could make it easier for them to adapt to new tasks, and specialized data sets for reasoning and dialogue could potentially improve their performance in those areas. It would be interesting to see how these approaches are used in the future.
Definitely. It's always exciting to see how research like this can be applied in practical ways. Thanks for the interesting conversation, Joe Prime.
Interlude baby. Hey, Ferris Prime, have you seen the latest paper on multimodal research? It's called Do Dali and Flamingo Understand Each Other?
No, I haven't. What's it about?
It's really interesting. The main goal of the paper is to improve machine understanding of images and text and to find ways to communicate meaningfully between both modalities.
Oh, I see. So what approach do they propose for achieving this goal?
They argue that the best way to select the most accurate image-text pairs is through an interactive task involving both text-to-image and an image-to-text-based generative model. They use DALL-E and Flamingo as the models in their experiments.
Interesting. And what are the results of the experiments?
They found that the generated textual descriptions were optimal and resulted in images that were most similar to the original images. They also found that the image simulated by the second model was close to the image the first model received as input, indicating successful communication between the two models.
Wow, that's really impressive. Do they have any recommendations for future work?
Yes. They suggest that further research could explore more advanced models and different communication protocols to improve the performance of the interactive task. They also suggest exploring the use of their approach in different domains, such as natural language processing and robotics.
That sounds really interesting. I'll have to check out the full paper and see the details of their experiments. Thanks for telling me about it, Joe Prime. So, Joe Prime, what do you think about this approach to matching text and images? It seems like an interesting way to improve machine understanding of both.
Definitely, Ferris Prime. The idea of using mutual improvement between the models to achieve better understanding of both images and text is really clever. And I like that they're looking at the gap between the representations learned by the two models to see if they share the same representation.
Yeah, and I'm excited about the potential for this approach to lead to more successful fusion of multimodal models. Do you think this is a promising direction for future research?
Absolutely.
Fine-tuning the models to skip the sampling process and generate the best samples directly is a really interesting direction to pursue.
It could lead to even more accurate and efficient multimodal fusion.
Definitely. It's always exciting to see new approaches to tackling these complex problems. Thanks for sharing this paper with me, Joe Prime.
Interlude baby.
Hey, Joe Prime, have you heard about this new paper on neural fields for video compression?
No, I haven't. What's it about?
Well, it's about using neural fields, which are a way of representing signals by mapping coordinates to their quantities using neural networks to compress video. The goal is to create a more efficient method for video compression compared to traditional algorithms like H264 or HEV-C.
That sounds really interesting. How do they approach the problem?
They propose using a frame-wise approach where the network generates a video frame for each time coordinate. This reduces the encoding time compared to the vanilla neural field architecture, and it performs similarly to standard video compression algorithms.
That's really innovative. What makes their approach different from others in the field?
They improve upon previous frame-wise methods by incorporating optical flows into the frame-wise representation. This allows the network to reuse pixels from other frames, which helps with parameter efficiency. They also use multi-resolution temporal grids and a more compact convolutional architecture to further improve compression performance.
Wow, that sounds like a really solid approach. Have they done any testing to see how well it works?
Yeah, they tested their method on the UVJ dataset and found that it outperforms other frame-wise methods in both video compression and frame interpolation. With quantization-aware training and entropy coding, it even outperforms widely used video codecs like H264 and HEVC, and it performs comparably with state-of-the-art video compression algorithms.
That's really impressive. It's always exciting to see new approaches that push the boundaries of what's possible in a field. Thanks for sharing this with me, Ferris Prime. I'll definitely have to check out the paper and see what else they've done.
So Joe Prime, it looks like the proposed F-nerve representation is really making waves in the video compression world.
Yeah, it's impressive to see such significant improvements over existing frame-wise methods. And the fact that it performs on par with state-of-the-art algorithms with the added bonus of being more parameter efficient and pruning robust is really promising.
Definitely. It's clear that this approach has a lot of potential for advancing neural representation-based video compression in the future.
Absolutely. I'm excited to see where this research takes us. Thanks for sharing this paper with me, Ferris Prime. It's always interesting to stay up to date on the latest developments in the field. Interlude, baby.
Hey, Joe Prime, have you had a chance to read that new paper on spatial modeling and deep learning models?
Not yet. What's it about?
It's called A Close Look at Spatial Modeling, from Attention to Convolution. It's really interesting. It takes a look at how well vision transformers model spatial relationships and how they compare to convolutional neural networks.
Oh, I've heard a lot about vision transformers. I thought they were the go-to model for most vision tasks.
Yeah, they've definitely been dominant in the computer vision community recently. But this paper suggests that conventional convolutions might actually be able to achieve similar or even better performance with the right training recipes.
Really? That's surprising.
What did the authors find when they looked at the attention maps in vision transformers?
They found that the attention maps showed a lot of query irrelevant behavior, meaning that they were nearly consistent across the entire global scope. This goes against the design philosophy of self-attention mechanisms. They also noticed that the attention weights were quite sparse, but when they trained a vision transformer with distilled knowledge from a convolutional neural network, they found that the attention map became smoother and focused more on objects. This led them to propose a new model called fully convolutional vision transformer, or FC vision transformers, which combines convolution and self-attention in a more efficient way.
Wow, that sounds really promising. What were the results like when they tested FC vision transformers?
They found that FC vision transformers consistently outperformed other models with comparable costs. It achieved 80.9 top 1 accuracy on ImageNet using only 14 million parameters, outperforming other models by 3.7. And it also had excellent generalization ability, performing well on downstream vision tasks like object detection and semantic segmentation.
That's impressive.
I'll have to take a closer look at this paper.
Thanks for filling me in, Ferris Prime.
No problem. Happy to help. It's a really interesting paper, and I think it could have some big implications for the field of computer vision. Wow, this paper sounds Really interesting. Can you give me a quick overview of what FC Vision Transformers is and how it works?
Sure thing, Ferris Prime. FC Vision Transformers is a model that combines the strengths of convolution and attention to improve efficiency and performance in vision tasks. It starts by taking an input image and processing it in 4 stages, each of which includes a patch embedding to reduce the spatial size and a stack of FC Vision Transformers blocks to model feature relations.
That sounds really cool. Can you tell me more about how FC Vision Transformers uses attention and convolution together?
Absolutely. So the authors of this paper noticed that attention maps in traditional models can be sparse and query irrelevant, which motivated them to try and connect attention with convolution. They did this by abstracting a global context and dynamically fusing it with local tokens, which resulted in the fully convolutional vision transformer. This model explicitly embraces the advantages of both convolution and attention, and the authors found that it performs well on a variety of tasks.
That's really interesting. I'm definitely going to have to read this paper in more detail. Thanks for the summary, Joe Prime.
Interlude, baby.
Hey, Joe Prime, have you heard about this new paper on dialogue summarization? It's called Strudel, Structured Dialogue Summarization for Dialogue Comprehension.
No, I haven't heard of it, but it sounds really interesting. What's it about?
Well, it's about using abstractive dialogue summarization as a way to boost an NLP system's performance on other important dialogue comprehension tasks.
That's really interesting. So how does it work?
So the paper proposes a new task called Strudel, which stands for Structured Dialogue Summarization. The goal of Strudel is to decompose and imitate the hierarchical, systematic, and structured mental process that we humans usually go through when understanding and analyzing dialogues. It's essentially a more focused and specific version of traditional free-form abstractive summarization tasks for dialogue.
That makes sense. So how do they test the effectiveness of Strudel?
They collected human annotations of Strudel summaries over 400 different dialogues from 2 datasets, Mutual and Dream. Then they introduced a new dialogue comprehension model that integrates Strudel into a dialogue reasoning module based on graph neural networks over transformer encoder language models. And their experimental results showed that Strudel is indeed very effective in providing transformer language models with better support for reasoning and inference over downstream dialogue comprehension tasks like dialogue question answering and response prediction, and improving their performance.
Wow, that's really impressive. It's great to see how abstractive dialogue summarization can be used to improve dialogue comprehension tasks.
Yeah, it's definitely an exciting development in the field of NLP. And I'm sure we'll see even more progress in this area in the future.
Definitely. Thanks for filling me in on this paper, Ferris Prime.
It's definitely something I'll have to check out in more detail.
Wow, Joe Prime, the Strudel framework sounds really impressive. It seems like it has the potential to greatly improve the performance of pre-trained language models on important dialogue comprehension tasks.
Yeah, definitely. And what's really interesting is that it provides a more comprehensive digest of dialogues compared to traditional abstractive summarization. This makes it more focused and specific, which should be really beneficial for the language models to learn from.
Right. And the fact that it's integrated into GIN-based dialogue reasoning module makes it even more powerful.
Yeah, and the results of the empirical experiments on dialogue question answering and response prediction are really promising. It looks like this Strudel framework could be a game changer in the field of dialogue comprehension.
Definitely. I'm really excited to see where this research goes in the future. Thanks for explaining it to me, Joe Prime.
Interlude baby. Hey, Ferris Prime, have you seen the new paper on shape compiler? It's about translating between text, point cloud, and program representations of 3D shapes.
No, I haven't. That sounds really interesting. I'm always amazed by how researchers can design specialized models for different tasks using different shape abstractions.
Yeah, me too. And this paper takes it a step further by proposing a neural shape compiler framework to perform compilation between the 3 different shape abstractions using neural networks.
Wow, that's really cool. It sounds like it could be a big step forward in shape representation and understanding.
Definitely. And the paper even shows that combining the learning of different transformation branches within a unified framework leads to stronger representation learning and improved performance on individual tasks.
That's really impressive. I can't wait to dive into the details and see how the neural shape compiler works.
Same here. I think it has the potential to revolutionize how we think about and work with 3D shapes.
Wow. This neural shape compiler sounds really impressive. It's able to transform between 3 different shape abstractions and achieve great performance in multiple tasks.
Yeah. And it's really interesting that they found that it benefits from joint training on all the heterogeneous data and tasks. That's something that I think could potentially have a lot of applications.
Definitely. And it's also good to see that they're acknowledging the limitations of the shape compiler and pointing out directions for future research.
Yeah, I think it's really important to be transparent about the limitations of any research like this. It helps to set realistic expectations and identify areas for improvement.
Absolutely. And it's also interesting to see that they found that clip embeddings aren't suitable for use when the text contains geometric details. That's something to keep in mind for future research in text-guided shape generation.
Definitely. So overall, it sounds like this neural shape compiler is a really promising framework for connecting different shape abstractions and could be a big step forward in the field of 3D multimodal learning. Interlude baby. Hey, Ferris Prime, have you heard about this new paper on large language models encoding clinical knowledge?
No, I haven't. Tell me more about it.
Well, it looks like these models called large language models have the potential to be really useful for a variety of applications in medicine and healthcare. They're capable of learning generally useful representations from medical corpora at scale. So they could potentially be used for knowledge retrieval, clinical decision support, summarization of key findings, triaging patients' primary care concerns, and more.
Sounds really interesting. I'm always looking for ways to improve my knowledge and understanding in the medical field.
Yeah, me too. And it looks like this paper introduces a new benchmark called Multi-Men K to assess how well large language models encode clinical knowledge and assess their potential in medicine. They used a combination of existing data sets and a new one they created called Health Search K.
What kind of results did they see?
It looks like they used 540 billion parameter large language models called PaLM and its instruction-tuned variant FlanPaLM to evaluate the performance of these models on the Multi-K benchmark. And it looks like FlanPaLM achieved state-of-the-art performance on several of the data sets, often outperforming several strong large language models baselines by a significant margin.
That's really impressive. It's great to see these models making progress and showing potential for use in the medical field.
Definitely. And it's important to note that the safety critical nature of the domain means we need to be careful about how we develop and evaluate these models to ensure that they align with clinical and societal values and don't perpetuate biases or misinformation.
Absolutely. I agree. It's important to be mindful of the potential impacts of these models and make sure we're using them ethically and responsibly. So, Joe Prime, what did you think of the second section of the paper?
I thought it was really interesting to think about the potential for large language models to revolutionize the development of medical AI. It's definitely a complex domain, but the opportunities for improving healthcare are huge.
Yeah, definitely. And it's great to see such a wide range of people coming together to collaborate on this project, from AI researchers to clinicians to ethicists.
Absolutely. It's important to have a diverse group of perspectives when tackling such a complex and important topic.
Agreed. And I'm glad to see that the authors are encouraging further conversations and collaborations to responsibly translate these findings into real world applications.
Definitely. It's crucial that we approach the use of large language models in medicine with caution and consideration for all stakeholders.
Absolutely. We have a great opportunity here to make a real impact on healthcare, but it's important that we do it in a responsible and ethical way.